Okay, so I thought we could cover query strings today. All right, so first thing is, what is a query string? And they are basically these magical strings that appear within our query. So you can see that we were very creative in naming these. Anyway, A greater than 3, A is a column, 3 is some number, and we did a comparison. And this query string on the right, it's a little more complicated. We have columns B and C. We do a square root on them. We do an addition with a variable, and then we assign that to a new column X. Both of those fall within the scope of query strings. Okay, so how do they work? Let's first look at this first one. A is greater than 3. A is a column, 3 is a number. So what happens is we take this string and we generate some Java code. And that Java code is representation of all of the logic expressed by this simple statement. Any questions on that bit? No. Okay. And then from that, we actually run the Java compiler to create Java bytecode. And then we do a hot load of that bytecode that we just made and into the JVM. And at that point, we can, the where update and other methods can use it to execute the query. So then we get to the question of variables. So in this example, we have z equals 99, and the query string on the right uses the variable z. So here we also do code generation, but within that code generation, we have to figure out what variable z is. And we use the same concept for Groovy and Python, but it works out a little differently. So in Groovy or Java, we have a class called the query scope. And that query scope, you can add parameters to it, and that's used in the code generation to resolve the values. In Python, we're just using the Python global variables. And so you can assign a variable there just by putting it into the global binding.
So is query scope for Python going away entirely?
Yes. Yeah, I think it was a mistake for it to be there. Okay, and so there are two ways that variables can be added to the scope to be used. One is manual and the other is automagical. So manually is like this top line here where the X value is explicitly being put into the global binding. Automagical is like the second case where the variable is just being assigned. So if you have a top level script, your variables automatically go into the global binding, and so you can see them and use them without having to explicitly add them to the scope of the query.
Is there a way to view the globals table, like get meta for globals or anything?
So for both the Python globals and the query scope, you can ask questions of it. Yeah. Yeah. So you can ask what keys are in there or what values. And users rarely have to do that, but it can be useful for debugging. I guess in the past we've had problems with like the variable I accidentally getting set. And then you can imagine that we have the I variable within the query scope, which is something I forgot to cover here. But you have a conflict between those two, and you have to ask which one is actually being used. Let's see.
So Chip, what is bit? I thought in update you should have.
Yeah, you're right.
Just assignment.
Yeah, I'm sorry. Yep. Yeah, you're right. That's just a bug in my slides.
Okay.
Yeah, that should have been another where. Yeah. Okay. So that's variables. So for performance, this has a few consequences. One is, if we're doing code generation and compilation and loading into the JVM, all of that stuff doesn't come for free. So the first time you do something, there are costs. But at the same time, the code that actually runs is Java bytecode, which will have higher performance than other ways of doing this. So there's good and bad here. And if you look in the performance logs, you can actually see the cost for compilation. That's rarely a thing of concern, but that data is there if you want to look at it. One other thing here is, let's say you have, this slide's also buggy. Both of these should be wheres. So in both of these circumstances, you're looking for a column is greater than 3. And so our code generation is smart enough to recognize that those two are the same code. And so those get auto-generated. The code that gets auto-generated would be the same for both. And the system knows that they're both the same. So next time, the second time you do the query, it just uses the existing code that it's already compiled. So it doesn't have to go through the generation and compilation and loading steps again.
Is there anything that it has to recompile when the table ticks?
No.
Okay, so it just happens once and then the new observations can be sort of fed in.
Right.
Okay.
Yeah. Right, and that's what I have here. So what questions are there?
I assume all these query strings should follow the Java syntax, right?
Yeah, I mean, it's like a very stripped down version of Java.
I know, but if you cannot use, for example, Python syntax in the query string.
Correct.
Yeah, right.
That's something we could always change if it becomes like a killer feature for somebody. But right now this is kind of our variant of Java. There are some other things I didn't get to include, like match filters, where it's not even Java syntax. You could say, in the where filter, you could say, you could ask questions like, I want A that's in a list of values that's not case sensitive. And the syntax for that is, it's not Java, it's not Python, it's just some special sauce we added in there.
Right. Yeah, well, I wish we have a more strictly defined query kind of syntax or language, so to speak.
Well, I'm sure we could write up a strict definition.
You didn't cover function calls and all that in the query strings.
Yeah, you're right. And since you worked on that, do you want to say anything?
No.
Yeah.
Except that, function calls.
Well played.
Yeah. So function calls work. They work as you would expect. In Groovy, they're done through closures, so they need to be in the binding. In Python, I think I don't know, Jianfeng, do you know which ways of using Python functions work?
What do you mean? As long as the functions are defined at the global level, then you can call it.
Right.
If you want to call a method, the object that has to be in the global, global.
Yeah. But have you tried it with lambdas?
No, I haven't. That's a good question. No.
Okay.
But I wouldn't. Who knows? Let's see. It should work, but
Yeah, but we should also try it.
We should try it. Yes. Yeah, definitely.
Okay.
And these, oh, sorry, go ahead.
Yeah, I was actually kind of build on your question earlier, Alex. When it comes to live ticking tables, number one, if nothing gets recompiled, how does something like, when Deephaven compiles this into this optimized Java bytecode and then runs like a where filter to find where the column A is greater than 3, if T is a ticking table and A is growing in size, how does that, I guess, how does the new, like, let's say you did an update or something like that where you printed out a true or false if A is greater than 3 or less than 3. How does that get run on the back end so that it's fast and can keep up with the ticking nature of and the live nature of a table?
Okay, so part of that is in the update model, which I'm guessing I haven't covered yet. And so when you get when a table changes, a message is sent to all of its children that says basically the rows that were changed. And so you would just have to run the calculation over the rows that were changed. So, instead of thinking of A as a variable or a whole column that gets executed over, think of it as, A is a column source, and we also have a set of indices that were changed.
Okay.
So does the bytecode that get compiled act more like a function than like a set of sort of predetermined?
Yeah, so it's taking your logic from the query string, right, and creating a function from it.
I see. Okay. So then it can use that to act on whatever inputs come in.
Exactly.
Without needing. Okay. I got it. Cool.
And then also, in terms of table indices, we have I, and K. From my understanding, I is just an integer and II is a long, and those are meant to be used in static tables. And then what exactly, and if I'm wrong, just correct me, but then what exactly is K and why is it what you want to use for a ticking table?
Okay, all right, so I and II are the same thing. I is just the legacy version. So there was a point when we didn't support subtables over 2 billion rows. And that's where I came from. Once we expanded beyond that, we needed to use a long value. So I and II are the row number in the table. And that works fine as long as your table is static. If your table is dynamic, then that value is totally unreliable. The K value is an internal indexing value, and I wouldn't try to associate any kind of meaning with it other than it is a magical number to get the piece of data you're after. And in all of the implementation, that's what's actually used because that number is consistent as the table ticks. Does that make any sense?
So you can use K to get some sort of value for this row, but trying to guess what K means, what K is for another row is not something you encourage, correct?
It's not that we don't encourage it. It's not going to figure it out.
Yeah, it's nonsense. Yeah.
Yeah, but if you are actually implementing something that needs to look at the table in real time, so for example, you make a new table operation or you make a listener to listen to the table, you're going to be using the K values.
Right. Okay. Yeah. And where this, like, the rubber meets the road on this in regards to the capital markets is always, people want to support EMAs very easily or other references to previous rows and things like this, windowed type of actions, and all of that is very hard all that is requires real thinking and real development when you're doing it on the updating tables.
Right. So are there any other questions on IK indexing or anything like that?
So I'm just curious about the I'm just curious about the implementation, like the pseudocode you have over there on the left in the yellow box, right?
Yeah.
And I know it's pseudocode, but I just want to know what I could learn about that so I can extrapolate more about how the actual function call works. Like, I guess the result, like this is going to be a Boolean, right? I mean, you're going to return, you're trying to evaluate if a where clause is true. So for each row, you want to know, did this row meet the predicate in the where clause?
Yes.
So you're just going to return a Boolean for each row. So column source then must be, I mean, am I looping over many rows in the in this function, or am I just getting called once per function, once per row?
These are all great questions, and I thought about it last 12 years ago. So I think if you want to look at the latest thing, maybe ping Charles and ask him how to see it.
Okay.
My less educated answer though is that it's not record by record, that actually this is implemented in such a way that it's delivering a chunk of data.
Yeah.
And it's delivering an array and it's yielding an array of Booleans and but I mean I just used a massively broad stroke there.
Yeah, I think it's more complex than the simplest assessment.
Okay. Well, that's why I wanted to extrapolate, though. I mean, if it's oversimplified, and I take something that's oversimplified and I extrapolate from that, like that's awesome, right? Because I'm just spreading oversimplifications everywhere, and then everything's simple, and then it's no problem, right?
It's so easy to talk about.
Right, right. I mean, two hand waves in a point, and you're like done, man. You're
Right. Any other questions? Seems like there's a lot of discussion and interest on this one.
This
This makes a lot more sense than before, so I really appreciate this.
This is not a question, but this is something cool that you can do with these. Because these are just strings, they can take in lists of strings as well. And if you want to use user input to somehow define a set of query strings that you might not know before you get the user input, you can just write some code to generate strings, and then it works as though you went and typed them in yourself. So because these work with lists, you can basically generate these queries on the fly using whatever kind of user input you want, and it can communicate with the update system and update things without having to actually go in and write these queries if you do that right, which is what I just did this morning.
Yeah, so you can use things like list comprehensions to fill in a bunch of update strings.